same direction, but okay, same direction, start at different timing. Okay, same direction, start at different timing, closing the gap. So what I mean here is that, okay, the faster object which starts later usually overtakes the slower object before they reach the destination. Since they start at different time, there will be a distance between them at the start. Okay, now let's take a look at the example here. Okay, at 10:30 a.m., a cyclist started traveling on a road at an average speed of 30 kilometers an hour. Okay, so at 11:30 a.m., the cyclist started first. And then at 2:30 p.m., a motorist started from the same place. So the motorist start at a later time, traveling on the same road. If the motorist took 4 hours to catch up, so in this question, we note that the speed of the motorist must be faster than the speed of the cyclist, right? That is why even though the motorist start later, but eventually it can catch up or overtake the cyclist. Okay, and how long does it take? Motorist took 4 hours to catch up with the cyclist. Okay, all right. Now let's draw the timeline. Let's draw the timeline. Okay, let's put all the information inside so that we can understand and visualize the question better. So at 10:30 a.m., cyclists traveling at 30 kilometers an hour. So this is the speed of the cyclist. Okay, started traveling, okay, to this point, and then at 2:30 p.m., okay, at 2:30 p.m., the motorist started. So that means at 2:30 p.m., the cyclist would have been ahead of the motorist. Okay, why? Because the cyclist starts first, right? So at 2:30 p.m., the cyclist would be somewhere ahead of the motorist. So what happened here? It took 4 hours to catch up. So that means when does the motorist catch up? At 6:30 p.m. Do you know how I get 6:30 p.m.? Very simple. 2:30 p.m. plus 4 hours, right? 2:30 p.m. plus 4 hours is 6:30 p.m. So at 6:30 p.m., the motorist has caught up with the cyclist. Okay, so at 6:30 p.m. here, so that's why I put the cyclist and the motorist together. All right. Now, how do we calculate the average speed of the motorist? When the motorist catches up, the cyclist had traveled for 8 hours. So how do you get 8 hours? Okay, so from 10:30 a.m. to 6:30 p.m., right? The cyclist would have traveled 8 hours. Okay, so you can calculate 10:30, right? 11:30, 12:30, 1:30, 2:30, 3:30, and so on, and you get 8 hours. So the total time taken by the cyclist is 8 hours. And since we know that the speed of the cyclist is 30 kilometers an hour, we can find the distance, right? So distance is speed times time. Speed is 30 kilometers an hour, time is 8 hours. So you get 240 kilometers. So that means from here to here, the point where they meet, okay, the cyclists would have cycled, or both of them would have traveled a distance of 240 kilometers. All right, so find the speed of the motorist. So since speed is distance divided by time, okay, the distance is 240 kilometers, right? So the motorist and cyclist, when they meet up, the distance must be the same. Take note about this, because why? They start from the same point, right? When they start from the same point, the point where they meet up, okay, they start at the same point, even though different timing, but when they meet up, okay, when they catch up, right, the distance must be the same, right? So the distance here is 240 kilometers, but the motorist had taken only 4 hours, right, not 8 hours to catch up with the cyclist. So 240 divided by 4, you get 60 kilometers an hour. So you can see here, we we can check, right? We can check that. We see that the motorist is 60 kilometers an hour. The cyclist only 30 kilometers an hour, right? So you can see that the speed of the motorist is twice of the cyclist. Because he is faster, the motorist is faster. That's why the motorist is able to catch up with the cyclist. Okay, so you can check that our answers make sense. Our answers make sense. Okay. All right, quite a bit of a handful for some of you. Okay, let's move on to